Hey there, Physics 20s, Mr. Jukley here. We got a bit of a broken up lesson here. It's lesson 4 out of unit 4, all about energy. So the first part of it is the elastic potential energy, which is mostly enrichment. I do want to talk about it a little tiny bit so you get the really, really big ideas. So be very clear what you need to know and what you don't need to know for this one. But mostly enrichment for elastic potential. And then our energy conversions, which is part 4B, is going to be essential. Sorry, there's just an announcement that interrupted me there and made me lose my train of thought. So yes, lesson 4B, it's energy conversions. It's no math whatsoever. It's very simple, should be very quick, and we should understand how these energy conversions are going to happen. All right, so let's jump into it. If you're not already there, we are on page 126 and starting off about elastic potential energy. So this first section here, this is enrichment. And it's just sort of the idea that we've got, for any spring, there's a spring force that you stretch a spring out and it wants to get back to its original shape. So we can use this formula, Fs is equal to K times X, in order to figure out that spring. The negative you ignore. Perfect. Okay, so that's all we really want to talk about there. The stiffness of the spring is measured in K, so K is our spring constant. It is newtons per meter, so it's how many newtons it takes to squish or stretch a spring by 1 meter. Still part of our enrichment. Good, good, good. And then our, okay, so yeah, we've got different spring constants. So an elastic band is going to be fairly small, 20 newtons per meter. A car, 7 kilonewtons per meter, quite a bit more. Okay, this part is essential, just that we know what elastic potential energy is. So it's the energy stored due to stretching or compressing an elastic material. So anything that gets bent, squished, anything like that out of its original shape, and it wants to get back to its original shape, we've got spring potential energy. So this springboard, person's happy because they're bouncing up and down. This person should be happier because they're shooting bows and arrows. But things are compressed or stretched and they want to get back to their original shape. So this, if you get anything out of this, is just what elastic potential energy is. Our formula for this, and again, this is getting into enrichment. Our formula for this, ES is equal to 1/2 kx squared. So if you're doing any of the problems that involve spring potential energy, know that those are our two formulas. Fs is equal to K times X, and ES, that's our spring energy, is equal to 1/2 kx squared. Again, you will not need to do any of those, but if you want to, go wild. Okay, so now back to essential stuff. This is on page essential stuff, page 100, I believe it's 27, yep, 27, and we should understand, so we've got 3 types of energy now, and we should understand how they go from one thing to another, so how energy is converted from one object to another or from one form to another. So that's sort of the big idea. Let's review those 3 types of energy that we really got here. We've got gravitational potential energy, spring potential energy, and kinetic. How do we know that we've got each of those? Well, if I'm thinking about kinetic energy, we know we've got it because of speed. So I'll even write this out. EK, we know we've got it because we've got speed. Gravitational potential energy, EPG, how do we know we've got it? We've got height. And then spring potential energy, so EPS is what I typically call it. We know because we've got compressed springs or elastics or whatever, right? Something that's stretched, compressed, out of its shape, wants to get back to its original. So those are the 3 types of energy that we're going to deal with. We've also, notice, got work. And work could be work done by, say, friction, by applied forces, things like that. And work, remember, is our change in energy. So with these energy conversions, there's actually 2 videos that are pretty cool to check out. This OK Go is a music video. If you just Google search "OK Go, This Too Shall Pass," watch the music video. Enjoy. It is fantastic. It is all shot in one complete shot, which is kind of neat. And it shows you a Rube Goldberg machine. And I'm sure once you watch the video, you'll figure out what a Rube Goldberg machine is. And try and keep your eye on some of the energy conversions from kinetic to gravitational to spring, and also work to help us change those energies. So try that one out. And then there's also this one we can watch. This one's more cute than anything. Audrey's Rube Goldberg Monster Trap. You can Google search that one as well. And it's 5 minutes of your time. Pretty entertaining. Anyways, you can put the video on pause and check those out right away. Go for it. Alrighty, so when we're talking about energy conversions, anytime we do work, there must be a change in energy. That is something we talked about all the way from lesson 1. Anytime we're doing work, we're changing the energy. So there are 2 ways that energy can change. One way is by changing the type of energy that we got. That's an energy transformation. So for example, if a ball is thrown upwards after it leaves the hand, well, it's got lots of kinetic energy, and as it goes higher and higher and higher in the air, it gets to its maximum height. At its maximum height, it actually has 0 kinetic energy, but it's got lots of gravitational potential energy, right? So going from kinetic to gravitational potential energy. That's a change in the type of energy. You can try this out. Throw anything up in the air, your felt pen, your pencil, your eraser, whatever it is, throw it up in the air. It's going fast at the bottom, and it's going to go slower and slower and slower as it moves upwards. That kinetic energy at the bottom is going to turn into gravitational potential energy at the top. So an energy transformation. The other type is an energy transfer. So I've got green car driving along, blue car's here at rest, green car smashes into blue car. Right, it's a big collision here, and blue car starts moving. So before, green car had kinetic energy and blue car had nothing. Afterwards, green car still might have some kinetic energy. It's just going to be less EK, whereas blue car is now going to have some kinetic energy. So some of that energy has been transferred into a different object. And how do we transfer energy? Let me say work is equal to a change in energy. So the green car must have done work on the blue car to change its energy. Cool. Okay, so let's just think about a quick illustration here. So a person falls from a maximum height and lands on a trampoline. Let's describe the energy conversions. You could even put this on pause if you wanted to and try and figure out. So they're at a maximum height, and at a maximum height, remember, we've got 0 speed. So put it on pause. You can think that one through. What's going to happen to them as they fall, as they hit the trampoline, and as they get shot back upwards. Cool. Put it on pause now. Okay, so if you've had a second to think about this, we can go through and we can check this. We're just looking at our main energy conversions. So from the maximum height, where we've got gravitational potential energy, and I know that because I've got height, we're going to go down to the surface of the trampoline, and that's going to be at our maximum speed. We're going to have kinetic energy. So the gravitational potential is turning into kinetic. Let's see. Then the kinetic, once they start stretching out all the springs on the trampoline, we're going to go from kinetic to, well, what's that stretch one again for springs and stuff like that? Oh yeah, we're going to spring potential energy. Cool. So spring potential energy stored in the springs of the trampoline. And then, I'm not sure if that goes much further. What happens when the kid starts to get shot back up in the air? The spring potential, we could take this to the next level, EPS is going to go into EK, and then EK is going to go into EPG. So as the kid gets shot back up into the air, turns back into gravitational potential. When the kid's at the maximum height, they're going to start to fall back down, back into kinetic, and this cycle is going to continue. So hopefully we see the idea, right? It's one type of energy turning into another type of energy. So this activity that we got, this one is actually in your workbook on page 127. Consider an object at rest that's getting launched from a spring ramp and landing in the water. Assuming no air resistance and no friction, besides the friction of the box and the water at the end, could we describe the main energy conversions that are going on? So step number 1, it's starting from rest, but it's on a compressed spring. So on a compressed spring, that speaks to me, EPS. We are starting with elastic potential energy. And then it is being shot, and it's gaining a ton of speed. So it's gaining a little bit of height, but it's gaining a ton of speed. So the main energy conversion is that EPS is going to be turning into kinetic. Again, a little bit of gravitational, but the big conversion is spring energy into kinetic energy. Now at the top of the ramp, the thing's going to continue moving upwards. Right, so it continues, it goes from here up to its maximum height way up here. So I'm going from kinetic energy, that's at its maximum speed, to gravitational potential energy at its maximum height. And again, it's being shot sideways, so there's still a little bit of speed. There would still be a little bit of kinetic energy, but the main energy conversion is we're going from kinetic to gravitational potential. Now the next piece of this, once it's at the top, it's going to start to fall downwards. As it falls downwards, we're going from the top, and at the top we've got lots and lots of gravitational potential energy, to right before it hits the water, we're getting more and more and more speed. Well, that's going to turn into kinetic, so gravitational potential turning into kinetic. Cool. And the very, very, very last thing that we're going to do here is it's going to hit the water, it's going to cause a huge splash, and it's going to start to move through the water. So we're going from kinetic, it's going as fast as it can right before it hits the water, and then it's going to displace that water. So it's actually going to do work on the water. So it's going to transfer energy into the water, and it's going to go to heat. It's going to go to like the kinetic energy and gravitational potential energy of the water as it splashes upwards over here. So very, very last step there. Cool. So long story short for this, and we haven't actually mentioned this term yet, we are following our conservation of energy, which says energy can't be created or destroyed, only changed. So I'll say that one more time. Energy can't be created or destroyed, only changed. For you chemistry people out there, you'll also know this as our first law of thermodynamics. So first law of thermodynamics is the same as law of conservation of energy. Energy can't be created or destroyed, only changed. And that's what we've seen in every single case. It's changing from one type to another, or it's going from one object to a different object. So from one type of energy to another type of energy, from one object to another object. So this is a nice short little lesson. That is it for today. And the only practice that you really have for this one, the only essential practice that you have for this one is page 128, question 4, all about the West Edmonton Mall water slide. See if you can figure out the energy conversions as the person gets from the top to the bottom. The rest of those questions are all enrichment, and you don't necessarily need to have a look at them. Again, feel free if you want to, but focus on the essentials first. Anyways, Physics 20, that is it for now. I'll talk to you again soon.